What's up, YouTube? It's your favorite math teacher, Mr. Stevener, coming at you with another video. Before we get started, hit that subscribe button. That helps me bring content directly to you. I've already got subscribers asking me help with different videos, right? I've got one coming later on quadratic equations, all kinds of stuff. So no, if you're a subscriber and you've asked for help, I'm making it. It just takes time. Today, we're talking about, you guessed it, simplifying expressions. Well, at least I think you guessed it. You clicked on the video, so you should know, right? So, without further ado, we're going to talk about these. Let's get started. Bring Tommy over here. Tommy, you over here?
Yeah, I think so. Ow, hey, hang on. My leg is stuck. Hang on. Oh, hang on. Look, hey.
Let me get it. Hang on.
Ah, okay. Thank you.
You're welcome. I can't find my pencil. Where'd it go?
I don't know. It wasn't my day to watch it.
Did you eat it again?
No, I swear I didn't this time. I swear.
Oh, it's in my lap.
Oh, my goodness.
Sorry. Anyway, where were we at, Tommy?
You were saying something about simplifying expressions.
You were. Simplifying expressions. That's actually what we're going to be working on. Okay? You with me for that?
Well, I think I have to be, don't I?
Well, I guess you kind of have to be. You're right. So check it out. You were asking me, why are we going to use this, right? Or when are we going to use this? And I thought of something. I have a quote for you guys. And I think you're going to like it. You might Google it. Somebody else has already done it. But I don't think they have. So check it out. In math, a lot of kids always ask, when are we ever going to use this in life? Or why do we need to know this? So check it out. I thought about this because I often told you guys the why. But now I'm going to stop doing it. And here's why.
That's lots of whys.
There is a lot of whys. But check it out. Here's why. If you know the why, but don't know the how, then really there's no reason to know the why. Right? I think it's much more important to know the how so that when why comes along, you know how to do it. Does that make sense?
I think so. Hang on, say it again.
Let's check it out. The why is not as important as the how, right? Because if you know how to do something, when the why comes along, you'll be ready, right? But if you know why and don't know how, then what's the reason for knowing the why?
That's a really good point.
Yeah. So something to keep in mind. Like, for example, just example, my math lesson, example in life. If you know why in basketball their goal is to make it into the basket, but you don't know how to do it, what's the point? Right? But if you know how to shoot a basket and you discover why you're shooting the basket that way, then you already know how and you're an expert.
Oh, man.
Just like math.
That's a good quote. I like it.
I like it too. Something to think about, right? Throwing that out there for you guys.
Thanks. That was kind of good.
I appreciate it. So, we're going to take a look at our first problem here. There's some things that you need to know with expressions. Okay, first off, they cannot be solved.
I can't?
Nope. So don't try to come up here and just start combining all these things and solve it. They cannot be solved. Solved is not something they can be.
Really? Then what are we doing?
Well, you're going to find out in a second. You're not solving them, you're simplifying them. Simplifying is another way of making it easy to look at. And we're going to talk about that in a second. Because eventually, you'll learn how to evaluate this as expression, which will be another video. Okay? And to do that, you have to first be able to simplify it. So we're going to start by there are parts of an expression called terms. This is really important. Tune with me. And by the way, guys, I'm going to show you the progression from easy to hard, getting to the things that you're going to see that are difficult at the end. So stick with it. Watch it if you've watched so far. So terms. Terms are basically the parts of the expression that are all separated by these. Keep in mind, this guy right here means multiplication. You just won't see the x as much anymore.
Oh, okay.
You're going to see this little dot. So all of the terms, so that means this guy right here is a term, this guy's a term, this guy's a term, this guy's a term, and this guy's a term. Notice they're all separated by operations.
Ah, I get it. Yeah.
Okay, there's two types of terms. There are variable terms. A variable term is basically a term, that is not a variable term, that has a variable with it. Z, Y, X, dot, fill in the blank. You with me?
Yeah, I think so. It has a variable with it.
Exactly. Then there are what they call non-variable terms, or constants, okay? And basically it's this simple. A constant is a number by itself without a variable.
Huh, like what?
Like the number 8 right here.
Oh.
Another term you might need to know is this number that's next to the variable, okay? You're going to see that every once in a while. That's called the coefficient. And I don't know if I spelled that right. I'm not a spelling teacher. I'm a math teacher.
Yeah, I know. Believe me, you can't spell.
Thanks. So that's a coefficient. So the coefficient is the number next to the variable. The constant are numbers by themselves. And all of these are terms, right? But then you have variable and non-variable. You with me?
Yeah, I think so. This is good so far.
Okay, so I'm going to teach you how to simplify it. I use the shape method. At least that's what I call it. I don't know if that's a real name for it, right? And these are basically the shapes I use. I use what I call a circle, a triangle, a square, and a little squiggly cloud thing. Oh, if I need to make up more shapes later, I do. But in this case, we're going to look here. Are you with me?
Yeah, I think so.
So check it out. I'm going to start by making a circle around my first term. This is my constant. So now I'm going to look for other what they call like terms, because my goal in this is going to be combining like, I'm going to emphasize this word right here, terms, okay? That means that basically these terms, I'm looking for the ones that are alike, okay, or the same. All right, so bear with me. Then I'm going to combine them. That's how I'll simplify it, okay? Now this next term, I'm going to look, is this a constant?
No, it's got a Y on it.
Yep. This one?
No, it's got a Z. No, it's got a C. No, it's got a Y.
Exactly. So I've got no more constants. I'm done with my circle. Now move on to my triangle. Now here's what I'm going to do. I'm going to triangle this. Notice what I did, Tommy.
Wait, why did you do the negative?
Exactly. I had to put the subtraction sign in there because the sign always goes with a number directly following it. So this number right here, the 3y, has to have that subtraction sign with it. That makes it a negative 3y. That is really, really important.
Okay, first important rule. Got it.
First important rule. Good call. Now, this guy does it with it.
Yeah, because it's a variable term.
Ah, this is really important. That doesn't go with it.
Why not?
Because one is a y and one is a z. Here's a good way to look at it. If I had 3 apples and you had 4 oranges, right? And I get you and I say, oh, look, I have 3 apples. And you're like,
I had 3 oranges.
right. Would I say I have 7 apples?
Well, no, because you don't. You had 3.
Exactly. But I would say I have 7 fruits, right?
Yeah.
So keep in mind, fruits are like the variable terms. So these are all variable terms. They're all fruit, but they're not the same fruit. Y and Z are not the same. So this is really like having 3 apples and 6 oranges. They don't go together.
Oh, okay. I think I get it.
So no triangle on that one. What about this one?
No, because it's a Z, right?
No, because it's a Z. You're right. About this guy.
Oh, because it's another Y. It goes with it.
Exactly. So that makes it a like term. And notice it put the addition in front of it, right?
Got it. Okay, cool.
Now move on to this. Done with that triangle. Move it on to square. So I'm going to put the square on the 6Z. And then I'm going to put it around the...
Negative 4Z because it's alike.
Exactly. Because the Z's go together. All right? So I'm done with all my shapes. I didn't even need to use my cloud that time. And now combining is just putting them together. All right? So I'm going to bring down my 8 because I've got no other circles. Now I'm going to combine my triangles. All right? It's a negative 3y plus a 10y.
Wait, that's adding integers.
Right. So if you're struggling with adding integers, go watch this video.
Yeah, go watch it. I watched it. It's cool.
All right. So now negative 3y plus 10y, that's a 7y. This is really important too, Tommy. Some people just put 7 and move on. That variable doesn't disappear. It has to stay with those, right? You can't be like 3 apples and 10 apples and be like, oh, look, now all of a sudden I have 10.
Well, yeah, you have to say 10 apples.
Exactly. You have to say 10 apples. In this case, you have to put 7y. This one's 6z. Take away 4z is 2z, and you're literally done.
Wait, that's it? You don't go any farther?
You can't go any farther because this is just simplifying it. Doesn't this look a lot easier than that thing up there?
Oh, yeah, it does. So that's it?
That's it. There are some curveballs I'm going to show you in a second, but literally it's the shape method. Just combining terms.
Oh, man, okay, just combine. That's it?
Yeah, let's look at another problem. So, this one, we're going to try it. You ready? You go fast with me?
Yeah, let's do it. Do it. Here we go. A circle. Negative 4. Yep, got it.
This one?
No.
This one?
No.
This one?
No. But yes. It's negative 7. Circle it. Yeah. Wait, why is that a plus negative?
Sometimes it happens. You'll see a plus and negative. It's really just the same thing. It's a takeaway. But we can put both terms in there. Here we go. So we'll just do this. That term I think goes with that, but plus and negative is the same as subtraction, so it's okay. What about this guy?
No.
All right, new shape. Let's do the square for the second one this time. My negative 7c, does that go with it?
Yeah, because it's a C term, and it's a variable term. Yeah.
Good job. But this one?
Yeah.
Good. So now I just combine them. Circles together. That's negative 4 and negative 7 is negative 11. Makes negative 21. Again, if you struggle with that, I'm going fast. Go watch that video. Because subtracting is something you're going to do a lot in life.
Oh, no, a lot.
So then I'm going to combine my squares. That's 1c, that's 4c, and you are literally done.
Oh, man, this is cool. Just the shapes made it look a lot easier. Look at that. Oh, man.
That is way easier, huh?
Yeah.
All right. This is where it gets tricky. So if you've tuned with me so far, you're about to learn something else that other kids don't know because they stopped watching the video. Check it out.
Wait, parentheses, what are those?
Parentheses, that's distributive property.
Distributive property? Yeah, okay.
Yeah, exactly. Interesting. So that means this 7 right here is going to multiply by every single number that is inside this parentheses, both variable term and non-variable term. So even if this 5 was inside of these parentheses, it would have to multiply by that too. Okay, that's called distributive property. So you'd have to start there first. Just like in order of operations, you start at the parentheses.
Okay, got it.
So I would bring down my 6p. 7 times 9 is 63. 7 times 8 is 56p. Notice I put the p in there. That's really important. That variable still goes with it.
Okay, got it.
Do I multiply 7 times 5?
No, because it's not in parentheses.
Exactly. So I just multiply what's in the parentheses. That's called distributive property. Now I bring down the 5. Now, what do?
Your shapes.
You got it. So I would just do my shape. So I'm just going to go fast on that p. That's not a p term. That's a p term. I'm going to use triangle this time and a triangle this time. I combine them, and I would get p's first, and that would be 62p plus 68. And you are done, my man.
Oh man, that's so much easier to look at. I like simplifying. This is great.
I like simplifying too. That's why I told you it's a really important skill. All right, last one. You ready, Tommy?
Yeah, I think so.
Last one. If you stuck with me this far, you're about to learn a secret that a lot of people don't know about distributive property.
Really?
This is the secret. Check it out. Most people would do this distributive property. They do what?
9 times 7.
It's not 9. This is really important. When there is a negative in front of this, remember how I said the sign goes with the number in front?
Yeah.
It has to stay with the number in front. So really this is a negative 9 times 7. And a negative 9 times negative 1. By the way, a negative times a negative is just a positive.
Oh, okay.
So I would bring down my 4w. Negative 9 times 7 is a negative 63. And a negative 9 times a negative 1 is 9. So it's a plus 9w. Keep in mind my w stays there. Minus 8. The trick to this one, Tommy, that negative number. If you stuck around, a lot of people don't know that, and they would get this wrong. That negative has to multiply. That negative 9 times that, negative 9 times that.
Oh, that's cool.
It is cool. So now I just combine like terms. Look for my shapes. Does that one go with it?
No.
That one. But I'm going to put my 9 in it. I'm going to use a square, negative 63 and negative 8. That's 13w minus, because this is negative and a negative, right? Take those away, and that becomes negative 71. And you are done, my man.
This is great.
And this will make it so much easier when you go to learn to evaluate expressions. I hope this helped. And don't forget, guys, for those of you who want to know why you're ever going to use this in life, the why is not as important as the how. Because if you know how, when the why comes along, you'll be ready. Right? But if you know the why and don't know how, then what's the point of knowing the why?
Yeah, well said. Also, subscribe and like. Okay, guys? Thanks so much for watching the video.